This is another problem in a hydrogenic atom. So we are supposed to compute expectation value of 1 over r for an electron in the ground state of a hydrogenic atom and use the result to calculate the following, that is average kinetic energy, average potential. So average potential energy and average kinetic energy. So using this result, okay. So first let us calculate this result. So solution to this problem is, so we have to calculate expectation value of 1 over r. We know that expectation value of 1 over r in computation of expectation value of r we have seen, we will get radial part as well as the angular part. Angular part is nothing but the spherical harmonics which is normalized, therefore anyhow that is going to become 1. So we can directly write down the expectation value in terms of a radial part alone. So you will get 0 to infinity, and this becomes modulus of RNL of r whole square, and this is 1 over r, right? So 1 over r, and the volume element will get only r square dr term, because other terms combining with the spherical harmonics and gives you the normalization, and they are normalized, therefore it gives you 1. So these two, 1 r gets cancelled now. So this becomes for ground state n is equal to 1, L is equal to 0, R10 of R is equal to, it is simply 2 Z by A naught the whole power 3 by 2 e power minus Z R divided by A naught. So the expectation value of 1 over R becomes 0 to infinity and modulus square, therefore it is 4Z by A naught the whole cube, and e power minus 2 ZR divided by A naught into R dr. So we can pull out the constant term 4Z cube by A naught cube. So we are going to solve only this integral 0 to infinity r e power minus 2Z r divided by A naught dr, where A naught is the Bohr radius, right? And for, this integral, so 0 to infinity x power n e power minus alpha x dx is equal to, so this is equal to n factorial divided by alpha power n plus 1, something like an Laplace transform, okay. So now here n is equal to 1 here in this problem, and alpha is equal to 2Z by A naught. So therefore this integral become 4Z cube by A naught cube into, and this is n 1 factorial is 1, alpha is 2 square, n plus 1 is 2, therefore 2 square Z square by A naught square. So this can be written as 2 square is 4, 4 gets cancelled, so 1 Z square, Z cube 1 Z is remaining, Z divided by, for A naught square A cube 1 A naught is remaining. So it is simply Z by A naught. So what it is, the expectation value of 1 over R is equal to simply Z by A naught. And note that the expectation value of R is equal to 3 by 2 A naught by Z. Okay, which means expectation value of R is not equal to just simply expectation value of 1 over R. That is, so what I am telling is, so the expectation value of 1 over R is not simply equal to expectation value of 1 by expectation value of R. So they are different, okay. So please note that. So expectation value of 1 over R is not simply equal to 1 over expectation value of R. This is because of this constant term, that is 3 by 2. Okay, now when z increases, this also increases. 1 hour expectation value of 1 hour also increases. Now let us calculate the first part. The first part of this question is using this result, the average potential energy. Okay, so the first part is the average potential energy. Now what is this potential energy? So we know that V of R, this is a Coulomb potential, which is minus Z E square by 4 pi epsilon 0 R. So expectation value of this, which is equal to simply taking the expectation value of these quantities. Okay, so we can pull out the constant Z E square divided by 4 pi epsilon 0 with the minus sign. We can pull out, it is simply expectation value of R, but the expectation value of R is simply Z by A naught. So Z E square by 4 pi epsilon 0 into Z by A naught. So it's simply minus Z square E square divided by, okay, 4 pi epsilon 0 and A naught. But A naught we can substitute. What is A naught? A naught is nothing but what? So A naught is equal to this is 4 pi epsilon 0 h bar square by m e square. Therefore we can substitute here. So expectation value of V of R, which is equal to minus Z square E square divided by 4 pi epsilon 0. Here instead of A naught I am just substituting 4 pi epsilon 0 h bar square divided by m e square. Okay, so this is the value for A naught. Now this becomes minus Z square E square, and E square, there is one more E square, therefore you will get E power 4, this E square combining with this E square, you will get E power 4 and m whole divided by 4 pi epsilon, the whole square is 16 pi square epsilon naught square h bar square. So this is the value for the expectation value of the potential. Now we can write down this as minus m by h bar square, and we can write this as z e square by 4 pi epsilon 0 the whole square. We can also write in this way. Okay, so by writing like this we can actually write in terms of the fine structure constant, which is a dimensionless constant. So by doing some simple algebra, so what we are going to do is just rearrange this. So m h bar square and z square, you can take it outside and multiply c square and divide by c square. So 1 over c square. What is actually this fine structure constant alpha is e square by 4 pi epsilon 0 h bar c. Okay, so we can actually take this h bar square inside, and e square, okay, therefore e power 4 16 pi square epsilon naught square. So this part alone we can take outside, mc square z square, and this is e square by 4 pi epsilon 0 h bar c the whole square, right? So this is actually alpha square. So minus m alpha square c square z square. So this is actually the average potential energy. Now we can calculate the average kinetic energy. So the average kinetic energy we have to calculate. Average kinetic energy. But we know that the total energy is equal to kinetic energy plus the potential energy. So the average, taking the average is E itself, which is nothing but sum of average kinetic energy plus average potential energy. So which means average kinetic energy is equal to simply E minus the average potential energy, right? Now what is this? Minus, and this kinetic energy which I am going to call T, okay, average kinetic energy minus, this is V of R. So what is E from Bohr atom model? This is, we know that minus m by 2h bar square, and for hydrogenic atom it is simply Ze square by 4 pi epsilon 0 the whole square, right? So we can substitute these results here. So this is minus m by 2h bar square Ze square by 4 pi epsilon 0 the whole square minus this quantity. This is also actually minus m by h bar square Ze square by 4 pi epsilon 0 the whole square, right? So this is minus into minus plus, and there is minus 1 by 2, there is a plus 1, therefore this becomes m by 2h bar square Ze square by 4 pi epsilon 0 the whole square, which is nothing but what? By simplifying like this in the previous case, so the same factors are there, minus mh bar square Ze square by 4 pi epsilon 0 the whole square. Instead here it is, instead of minus, we have just 1 by 2 as a constant outside, therefore this is 1 by 2 mc square Z square alpha square. So what is our observation? Our observation is, see, the kinetic energy, average kinetic energy is equal to, it is 1 by 2 mc square Z square alpha square. The potential energy, average potential energy is equal to simply minus mc square Z square alpha square. So which means the average kinetic energy is equal to minus 1 by 2 average potential energy. So this result is the quantum mechanical equivalent of the classical virial theorem. So this is the quantum mechanical equivalent of the classical virial theorem, okay, and this is not only true for ground state but for all bound state of the hydrogenic atom. So this is a very important result. This is not only true for it is not only true for ground state, it is true for all bound state of hydrogen atoms. Okay, so thanks for watching this video. Thank you so much.